Great, thank you. So my co-founder, Alex, is here. Alex, raise your hand. There he is. Alex likes San Francisco and Python so much that he actually flew down here from Seattle. So yeah, it's a real treat. So this is going to be an introduction to prediction in 5 minutes. So prediction in general is, there are things that are more predictable than others. In this case, there's a shark biting an undersea cable, probably not predictable, but perhaps we can figure out how many of these things are happening in a given year, but we can't predict any single individual event. I'm going to talk about predicting numerical things that are predictable. There are things that have different levels of predictability, so the assumption here is that what you're trying to predict is actually predictable. There's a wide range of applications for this, one of which is things like CPU data, which is something that we actually work on, is making predictions for server parameters. And in this case, being people, we can spot patterns, and we can see several patterns in this particular, this is a real CPU graph. We can see that there are kind of these cyclical increasing trends, and then we see a few spikes. So we can see that there are patterns here, or we can assume that there are patterns here. So the question is, how do we do this, algorithmically? How does a computer figure out if there's a pattern here? And generally, the easiest way is to do linear regression, right? So I have a bunch of data points. I'm going to draw a line through those data points. I have a slope, in this case beta. I have a y-intercept alpha, and we just kind of extrapolate out. So I'm going to have a Python notebook here. So we have some data points here. We can see that we have a little bit of an outlier, but in general they're sloping upwards. So this might be a good candidate for linear regression, right? So we generate a slope of the line that minimizes the error between the data points and the line, and we can kind of the red is historical data and green is things that we're predicting, and assuming that this pattern continues, then this is going to be all nice and good, and then we can, hopefully have a good prediction moving forward. But now, what happens if this data is cyclical? Let's try this. Oh well, that's not so good. So this is that same pattern repeated twice, and we do a linear regression for the historical data, and then you can see that the predicted data doesn't actually correspond to the actual data, so assuming the pattern is cyclical. So we can try to do something a little more sophisticated. We can try to do an exponential moving average. So basically, we weigh the more recent data higher than the historical data. So basically, the weight for the data decreases exponentially according to this factor alpha, so that we assume that what we're predicting is going to be closer to the more recent data point than it is going to be to a historical data point. And then this is what the equation for that looks like. And let's see what happens when we do an exponential moving average on our cyclical data. So we can see linear regression didn't really do a good job with this. Let's try to do, and the slides and the IPython notebook are going to be available for download in case you want to play with this data yourself. So let's see what happens when we do an exponential moving average. So it actually does a pretty good job here. There's other parameters involved with this exponential moving average. So besides alpha, so we can kind of tweak it a little bit, and we can see like, well, what happens if we change the window size for the data that we're looking at for this exponential moving average? And again, green here is predicted and red is actual. And if we do a different window size, a window size that matches the the period of the data, we see that the predicted data points are actually a lot closer to the real data points. And again, it's hard to tell whether this is going to translate well to other graphs, but we can see here that it actually does a pretty good job with predicting this cyclical data, and the actual computation involved for this is actually not that intense. And there's a library available for both exponential moving average and linear regression. And again, you can see that in the IPython notebook. There's other approaches. We can do higher dimensional polynomial fits, Fourier transforms, machine learning, Bayesian classifiers. There are things that people try to do in finance that you can actually use as well for any sort of numerical data. It doesn't have to be pricing. So these are the links for the data. You can see the slides and the IPython notebook that I had up earlier. And that is all. Thank you.